future. Okay, so this is what we did the other night. We defined the notion of a function. Okay, the function is a kind of a machine. So what you're going to do for this machine, you are going to drop an input, we call it X. Okay, we drop the X into this machine. This machine will do some operation, mathematical operation, like adding, subtracting, multiplying, taking the square root, cube root, and then they give us the result. So the result is going to be action of f on x. We call it f of x. So you give the x to the machine gives you an output. This output will be denoted by f of x or just y. So in this case, we say that the x is related to y. X is related to y by f. What is f? F can be a relation, can be an equation. It's an instruction that you give to the machine, or can have a formula, okay, a table, a chart. Okay, so this would be our function. So we usually use the notation y equal to the f of x for the actual equation of the function. So we try to give you some example in everyday life. The best example is your calculator. This is the calculator machine. Okay, so what you do, you have the x is your number. If you click on the square root, the machine should give you a square root of x. So y equal to the square root of x would be a square root function. So if you have the 4, you click into the square root, so that gives a radical 4, which is equal to 2. If you go back and you put the 9, you take the square root of the 9, that gives you 3. But these numbers must be in the so-called the domain of the function. The domain of the function for this one means the square root. We cannot take the square root of a negative number because we are not going to use complex numbers. So if you give the negative 4 to the machine radical negative 4, the machine cannot operate, give you an error. So this means this negative 4 is not in the domain of the function. So the function cannot operate for negative 4. Okay, so that's basically our tools that we're going to do. So this x is free if you like, but the y would depend on x. You have to wait to see what the function is going to do with the x. So we try to give you some examples in everyday life. Okay, we end up with the ATM machine. ATM machine, the input is you just, you insert your card, okay, into the machine, and then you ask for the money. The machine will bring your account, and the output is going to be the money that you're going to get. So I'm going to give you more examples. We should be able to connect this concept to everyday life to give us a better understanding of the subject. Okay, so we talk about it. The other machine is the gas station. Okay, so if you go to the gas station, the gas station machine is just a function. So you go to the gas station, what do? You just select, okay, you select the type of the one that you're going to be interested in, or you go and you pay for it first. How many gallons? So X is going to be the number of the gallons, if you like. The inputs are going to be, okay, gallons. So then you let the machine know, you pick, okay, you select the type. Okay, so it's a gallons, and you already pay the money. So this is going to be the dollars that you pay. So the machine, according to how many gallons to ask, what type of gas you are interested in, the machine will charge you f of x. So y equal to the f of x would be the amount of the money that they charge your credit card, or amount of the money that you pay to the cashier in advance. Okay, so the gas station is going to be a machine. It's going to be a function machine. The input is the number of the gallons. The output is going to be, okay, the machine is the charging machine. So we talk about all cashiers are going to be functions. Okay, all the cashiers. Any question? The other one, example, a very good one is the fast food restaurant. Okay, this is going to be fast food. Okay, fast food restaurant. So what would happen in these type of ideas is this is where the function would be denoted by a chart. You see, there's going to be the chart that you see. If you go to McDonald's, for example, so you will see the chart. The chart will tell you that, for example, the Big Mac, for example, you ask for it, they charge you what? They charge you something like $3. Then you just checking some fries. Okay, fries, they charge you differently. So again, the cashier is going to be the function. Okay, when you order, they bring the function and they charge you. So the fast food restaurants that give you the one. Okay, question. The one that you are going to having in calculus or in science is this one, number 5. Sometimes we may have to break the function. You see, this is just one equation, if you like. But sometimes you need to use several equations to give the definition of a function. The example of this type is going to be tax function. Okay, what would happen to the tax function? You see the tax function, the X is going to be your revenue. So it depends. It depends how much is or how many dollars you are going to make. So for example, if your revenue is going to be between 0, let's say between 0 and what? Between 0 and $30,000. So the machine would use the 10%. Okay, so they charge you 10% of the X, for example. But if you are going to be in different bracket, so if you are going to be in the bracket of, let's say, bigger than, you're making bigger than 30,000, just a guess, and this is going to be 100,000, for example. So the machine would operate with a 15%, for example, and it may go on. So these type of functions are the one that we're going to use in science. Okay, so your X, you see, you cannot define it by one equation only. At the beginning, they didn't believe in this type of functions. They just believed that the function must define by one equation only. But it was science that forced mathematicians to accept. This is going to be called piecewise defined function. We're going to talk about it later on. These are the best function for calculus, okay? So this is going to be called piecewise, I say it, piecewise defined function. And we're going to define it tonight, eventually. Okay, so the tax function. If you want to find another one as this piecewise one, if you go to post office, the post office function, okay, the post office function. What is the post office function? You know that when you go to the post office, you are going to put your letters, your parcel, okay, your package on the scale. You put it on the scale, okay? So you put the X on the scale. Then they, remember on the old days, they did have some booklet. They open up the booklet and they tell you how much you are going to pay for it. Now, of course, they have it online. So what they do for the package, so it's going to be the post office function, P of X. X is going to be the weight of your, okay, of your parcel. Again, they have different bracket. If the weight of the letters is going to be between, let's say, between 0 ounce, okay, and let's say, just a guess, and this is going to be 2 ounces. So you pay what? You pay nowadays 47 cents, 53, etc. So you pay only 43 cents. But if you have something which is heavier, if you have something which is going to be heavier, okay, heavier than 3 ounces, okay, let's say the 10 ounces, then they may charge you, let's say $2, okay, $2.50. And it's just going on. So the post office function is very good one in calculus. Again, it's going to be a piecewise defined function. Different brackets, the different way they are going to charge you. Any question? Can you give us an example of this type? Everyday life? Any suggestion?
Can you hear me?
Yes,
Okay, the gas station example,
yes.
if you scroll up, when it comes to the output, where did you end up putting like the money at?
The money is, the money, this is the money at the end. You see,
So you
because
don't bring the money sign down to like the equation at the bottom. You just leave it
no,
there
no, you
in the
see,
middle.
X is the number of the gallons, okay?
Right.
X is the number of the gallons. The machine check to see which type of the gas you selected. Okay. Then when the machine find out which type of the gas you selected, the machine would charge you. Okay, so this is going to be the chart of the gas. So if you pick the type 1, for example, if you pick the type 1, the one gallon, for example, is going to be what? Is going to be almost $4. So it depends how many gallons do you have. If you have 10 gallons, $4 each, then at the end of the day, the machine will charge you $40.
Okay.
You see, that's going to be the one. And you will see, that as you fill up your you see the money over there.
Okay. Thank you.
Okay. Any question? So the tax function is a very good one. These are the ones that we use in calculus. The post office, I just call it the post office because it's easy to understand now. The other one is your cell phone. Your cell phone is just a function again. It's a piecewise defined function, you see. Your cell phone, cell function or cell phone. What's going to be the cell phone? The cell phone is X is going to be number of the units. Okay, so if you like, if you call it C of X, X is going to be number of the units, minutes if you like, or hours. So we have a contract. The contract, you pay something like 60. Today's, it's going to be unlimited, but in the old days, you pay $65 for how many units? Okay, you pay this one for, let's say, 700 units. Okay, this is going to be 700 units, minutes, whatever it is. But if you go over, you know that they charge you differently. So if you go over that 700, then they charge you extra. They may have a special formula for it. Let's say they charge you $10 extra. So your cell phone is going to be a function. As soon as you dial, okay, your function is operating. You just check there. So your cell phone is going to be, again, a kind of piecewise defined function. Very good function. These are going to be. Any question? The other one is utilities function. Utilities, gas, electricity, water. You know that when they want to charge you, they have a special formula. It depends. Sometimes. So let me just give you that one too, because I wanted to get a good feeling of what is the function is about and how many are going to have. Okay, so this is going to be utilities, if you like. Utilities, okay, that's it, water, gas, electricity. These are going to be a nice piecewise defined function. The way they charge you, if you look at your bill, they explain it to you. They explain it to you that, oh, this is our formula for the electricity. They are going to tell you that, for example, if you have something like between 0 and, let's say, 200 kilowatt. So they have a formula for it, okay? So each kilowatt would be, for example, something like, $50, 50 cents, 60 cents. So your formula is going to be, this is going to be 50, it's going to be times X, the number of the kilowatts. But if you go to the next range, especially if it's going to be summer, okay, if you go into the higher range, it's going to be more expensive. It's going to be more expensive. They may charge you something like 70 for each unit, so you pay 70x. And they have another case. And then they say, oh, that's a one, but if you go for more than 500, so they may charge you something like 100x. So again, it's a very nice function. It's going to be a piecewise defined function to get the utility bills. Okay, if you are a business major, of course, you are going to have a cost function, a revenue function, and the profit function. These are the ones that we are going to work with in your case when we get to the application in future. Okay, so this is a notion of the function. So as you can see, everything you do in everyday life, it's a function. You see, the function that you will see in everyday life, you don't have to have the, f of x equal to the 3x plus 1. No, you go to a Starbucks, we talk about the menu of the Starbucks is a function because the input is going to be the type. Okay, you say coffee latte, white mocha, etc. And then they charge you the money. So in the Starbucks case, the chart is already given to you. So you have a look and you see it. If you go to the grocery store, it's the same thing. If you check the grocery store, they have a board. In that board, they just give you the name and the dollars that they are going to charge you. So these are very special cases, finite cases, but in general, we are going to have a kind of infinite case. Okay, any question? So this is a kind of everyday life functions, but the function is a machine. It's a mathematical machine. So that mathematical machine would have the variable x and a combination of powers of x. So you may use addition, subtraction, multiplication, division, square root, cube root, etc. So if we get back to these type of ideas, for each function to be able to operate, we have the domain of the function and the range of the function, especially the domain. So we are going to define the domain of the function. Any question? So make sure that anytime you want to think about the function, just have some examples. These examples that we talk about, just bring them up so that give you a better idea. Okay. So when we get to the operational one, it's all f of x, g of x, h of x. But make sure you understand that these can represent something live in everyday life. Okay. Now, what is the domain of the function? That's the important part. The domain. I'm going to define both of them, the domain and the range of the function. And the range, we mostly talk about the domain for the time being. In future, some of the range of a function. These two quantities, we defined it. Remember, the function would consist of two parts. The first part, inputs, x values. The second part, output, y values. X values means x, when we say x in algebra or in calculus, x, we call it a real variable. Real variable means x can stand for any real number. So we say x is a free agent. Okay, so that's going to be the x. If a function is given to you, y equal to the f of x, for example, those values that you are going to use for x or the x values is going to be the domain of the function. So the set of all inputs is called the domain of the function. This is where the function can operate. The set or the collection of all outputs, which means the y values, that would be called the range of the function, okay? So let's define it. If you give me a function, if y equal to f of x is a given function, okay, if this is going to be the given function, then the set of, okay, the set of all inputs. So we know that the input's going to be x values, possible number for the x. So if y equal to the f of x is a given function, the set of all inputs or the x values is the domain, is going to be the domain of the function, domain of the function f So this is going to be the domain, X values, inputs, and the set of all outputs. Okay, outputs or Y values. X values, Y values. Okay, and the set of all outputs or Y values is going to be the range. Is the range. The range of the function. So for each function in particular, you have to determine the domain of the function. So the domain means the restriction that you're going to put on the X. If there is not going to be any restriction, this X is free. Free means all real numbers. Okay, so it depends what type of operation are you going to use for the function. Okay, so let's give you some examples of what's going to be, especially how we're going to determine the domain of the function. These examples are going to be very important. It's going to be repeated at least 4 times. And you are going to see, this is going to be your tools, the functions that we're going to use in this course. So you will see it in any quiz, any test, you will see these type of functions. Okay, so pay attention to get these numbers. So what we'd like to do, we give you a function and you determine the domain of the function. Okay, so we'd like you to find the domain. Okay, find the domain of each function. We are mostly interested in domain. The range is going to be very much more involved to find. Okay. Now the first one, or the first group. The first one is this function, f of x equal to the x to the 4th. Okay, minus 15, let's say x cubed, plus 3x, minus 10. This is the function. We want to find the domain of the function. Domain of the function means what type of numbers can you use for x. So you have to check to see what are going to do with those numbers, what are going to do with those x's. So your function is going to be like a calculator. If you pick a number for the x, the function would add, subtract, multiply 3 times x, raise it to the 4th. You know, the powers are going to be just multiplication. So this number would do the addition, subtraction, and multiplication with the values of the x. So just think about it. Is there any restriction? Is any restriction if you want to multiply? Okay, if you want to multiply, you want to add or subtract the numbers. You know that there is no restriction. We can add any 2 numbers. We can subtract any 2 numbers. We can multiply any 2 numbers. So this means you can use any number you like for the x, because this operation automatically will go through. So in this case, say the domain of the function is going to be all real numbers. So the foundation domain, okay, this is going to be the solution. Okay, the entire domain that we have is a negative infinity and positive infinity. That is the number line. So to start with, you can pick any number for x, but you check to see what are you going to do with those numbers. Adding, subtracting, multiplying. We can add any 2 numbers, we can subtract any 2 numbers, and we can multiply any 2 numbers. So there is no restriction. X can be any number here. Okay, so the domain of the function, domain, we write it on interval notation. The interval notation would be a negative infinity, comma, a positive infinity. That's the domain of the function. You can use this notation. We prefer interval notation, or just you can say that the domain is just R, all real numbers. We prefer the first one, of course, all real numbers. Okay, so basically you can say you're done, of course, but I just explained it that the f is defined. We usually say that f is defined everywhere. Everywhere. So this means if I give you any number, you can substitute and you go through this machine. Okay, if you want to find f of 1, you replace the x by 1. F of 2, f of negative half. Okay, f of 3.5, 2.5. So it's free because the operations are just adding, subtracting, and multiplying. You know that if you want to divide, you got to be careful. You cannot divide by 0. And there is no division here. So there is no restriction. This function is defined everywhere, and the domain is all real numbers. Any question? This is the most popular case that you're going to use in this course. Of course, if you remember from algebra, we have a special name for this type of function. Do you remember? What do you call this type of function in algebra? You see, this is a combination of powers of x. You see the powers? We have x to the first, x to the third, x to the fourth. In algebra, a combination means sum and differences. A combination or combinations of powers of the variable x is going to be called a polynomial. Okay, so f is going to be a polynomial. So you have to get to know this name. So this is it. If it's going to be on the test, you can say that f is a polynomial. F is a polynomial as a polynomial function. And so is defined. Okay, it's defined everywhere. Or you can say that f is a polynomial and d is equal to the r. D is equal to the negative infinity and positive infinity. And we accept that, okay, we accept it right away. So most of your examples are going to be, yes, Paul, you're right. It's going to be polynomial functions. Any question? Give us one example of a polynomial function. Make one. Any suggestion? Make one polynomial function. That's a combination of powers of x. Pick any power of x you like. Anybody want to give us one?
Would one be f of x equals x to the fourth plus 16x to the third minus x minus 1?
Okay, you don't have to go, that far. Yes, Paul, you are right. This is, let's see, like, yes, g of x equal to, you see, x to the third minus 5x plus 1. It's just powers of x. You can start with any power you like. X to the 100 minus 5x squared plus 1. Okay, so these are going to be the polynomial. So you see, briefly, this is going to be is a polynomial or a polynomial function, and so the domain is negative infinity and positive infinity, or just r. We accept it. But you have to mention that it's a polynomial. Get used to it, because the polynomials are the easiest choice that we have, and we are going to use it quite a lot in this course, quite a lot. Okay, yes, question?
So is it correct that a polynomial will have the powers in order?
Yes.
Okay.
Yeah, when we write it down, we usually write the powers in order. You don't have to, but we don't usually write it down in order, yes. We call it a standard form. A standard means you start with the highest power and you go in down.
What that means, like, is that what determines it as a polynomial?
Yes, you know that
Okay.
in algebra, a power of a variable is called a monomial
Okay,
or
thank
a
you.
term. In this case, we have 3 terms. You see, 1, 2, 3. That's why we call it a polynomial.
Okay.
Yes,
thank you.
Marisol, what's the question?
So is the domain the same for all polynomial functions? Or-
Yes, yes,
Okay.
yes, you are right. All the polynomial functions, the domains are going to be all a real number. Yeah, okay, yes. The domain of all polynomials are the same. The polynomials are the easiest function for calculus, okay? So we are going to use this one. So from now on, you see quite a lot of the polynomials. Okay, any question? That's the first one. Yes, question? Marisol, do you have question?
Oh, no,
Okay.
sorry.
So that's the first group. Okay, the first group are going to be polynomials. Now what's going to be the next one?
Sorry, you said they're all gonna have the same domain. Are they all
Yes.
gonna have the same range?
Yeah, the range are going to be just the range would be different, depends.
Okay, just wanted to double check. Thank you.
Yeah, the range sometimes it depends. The range is a little bit more tricky. The range is, we can say that the range is just a subset of real numbers. Okay, but for the domain, we are sure that we are going to get it. Okay, so this is it. Yes, Paul, wait for the next one. Then you will see your question. Yes, you are right. Okay, now polynomials, in the case of the polynomials, you see we have addition, subtraction, and multiplication. Now, if you have a division, if you have a ratio, a fraction, of course, where the x is going to be down the denominator. This means you are going to divide it by x. In that case, of course, this is not going to be a polynomial. So that would be the second group, and this is going to be a rational function. So our next example is going to be rational function, very popular in this course, okay? So let's start with one. This is it. So suppose f of x is going to be equal to, we have a 3x squared plus 2 on the top. Then we have x minus 5 down the bottom. You see this one? You see, you have the addition, subtraction, and multiplication, and division. As soon as you want to divide, that's a red flag. You know that. If you want to divide, you must make sure that number is not 0. You cannot divide by 0. Remember, the x is free agent, because in this case, you see the top is a polynomial, the bottom is a polynomial. So x is going to be free solution. You see, again, you get your number line. It's from negative infinity to positive infinity. But the difficulty is just the division part. So you have to pick the values for x where the denominator is not going to be 0. So you check to see for what value of x denominator would be 0. Any suggestion? For what number denominator would be 0?
Positive 5.
Positive 5, very good. So x equal to the positive 5, denominator would be 0, but the top is not going to be 0. So we have to exclude the 5. So exclude the 5 means this is 5, take it out. You see, that's going to be the 1. So for this group, you let the denominator equal to the 0. You see x minus 5 equal to the 0. This is it. X minus 5 equal to the 0. So that gives you x equal to 5. So you find out that there must be a restriction on x. So x is not a free agent. X can be any number except 5. So this would be the domain of the function. So we partition the number line at 5. So how are we going to find the domain or write the domain? This is it. The domain is going to be equal to, you have 2 portions, you see, one portion here, and the other portion is going to be the other side. So we start with the negative infinity, we stop at 5. We stop at 5. Since we don't like the 5, we cannot have the 5, we use parentheses. You know that if you do have the 5 or want the 5, you have to use bracket here. So make sure don't use the bracket. And the other part, union, this is the notation that we're going to use. Union of what? Start from the 5 and you go to the positive infinity, Again, for the positive infinity, you use parentheses because you cannot reach the infinity. And for the 5, since you don't have it, is going to be a parentheses. So this would be the domain of the function. Okay, so for the rational functions, you got to be careful. You check to see where the denominator is 0. You find those numbers and then you exclude it. You remove it. You remove the 5. This function is going to be called a rational function. A rational function because you divide it. You're dividing by x. Okay. Now, in this part, you see if 5 is going to be part of your domain, you use bracket. If not, you have to use parentheses. Because if you put x equal to the 5, the number would be 0. So you exclude the 5. Exclusion would be the parentheses here. Okay. If you put the bracket, you are not going to use bracket for the rational function. Okay. This is going to be the one. We don't care about the top. Okay. We don't care about the top because the top can be any number. It doesn't matter. If the top is going to be 0, 0. So everything would be 0. Because in the case of the division, you have to worry about, the divisors. You cannot divide by 0, okay? If you put the 5, you see 5 minus 5 would be 0, but the top would be what? 5 squared, for example, 25, 3 times 25, 75, 77 divided by 0, never. You can't do it. Okay, so officially this is, just for your information, f is a rational function. F is a rational function and is defined, is defined everywhere, except at x equal to 5. But we like this one, okay? Mathematically it's correct even if you write it down. But we'd like you to just give us that interval notation for the final part. Okay, so it's a rational function. It's not a polynomial, it's a rational function because you're dividing by x over there. And since the denominator is going to be 0 at 5, so you must make sure that you exclude the 5 to get this number. Give you another one. Any question? So you are going to see quite a lot of these rational functions. Sometimes you may have more numbers to exclude. So this is going to be the next case. The next case is going to be, suppose you have a g of x is equal to the, let's say 5x plus 7 on the top. But we have x squared minus 4 on the bottom. See? Again, is a rational function. Okay? Is going to be a rational function. Though the infinity is always excluded, not included. You see infinity here? You have to exclude parentheses because infinity, you cannot find the infinity. You won't get to the infinity. So for the infinity, it's always parentheses, always parentheses. We don't use bracket. Okay, now let's see what's special about this one. About this one, this is x squared minus 4. And you know that you can factor it if you like to find out how many numbers are going to exclude. So remind yourself, okay, this is going to be the solution. Remind yourself that you have to factor it. Okay, so the top would be 5x plus 7. You know that x squared minus 4 can be easily factored into what? X minus 2 times x plus 2. Now find out for what value or values of x the number that would be 0.
Plus or minus 2.
Plus or minus 2. Plus or minus 2 because we have two cases. Okay, so just plus or minus 2 would be fine. So what we are going to do is we are going to get that number line again. In this case, we have to exclude two values. We have to exclude the -2 out, and the +2 out. And how we get this point, I just remind you, you see, x minus 2 times x plus 2 equal to the 0. That give you two solutions, x equal to 2 and x equal to the -2. This is how we're going to find those, those numbers that we have to exclude. Okay, so in this case, the number line is partitioned in 3 parts, you see, 1, 2, 3. So what's going to be your domain? The domain is going to be equal to, just read this boundary point we called it. So you start from -infinity, you stop at the -2. Remember all parentheses because you don't have it. Then you want to get to the next one, just union with what? Between -2 and 2. Parentheses, -2, comma 2. Then we have the third partition. The third partition is union with 2 and +infinity. So that gives you the domain of the function. Or you can say that, you can say that this function is defined everywhere. This function is defined everywhere except at x equal to 2 and at x equal to the -2. So that's going to be the ideal. Okay, so be prepared for it. The first one, the numerator happen to be 0 at one number. Okay, x equal to 5 only. But over here, when it's going to be x squared, you have to factor it. You factor it because each factor would give you one solution. It's give you one number that you have to exclude, if you like. Any question? So that's a type 2 of the rational function. There are a couple of tricky one. Just to make sure that you're not going to miss it. Let's see what is special about this one. Okay, go with something like h of x. Okay, we go with the h of x, and the top is going to be x plus 7. X plus 7, the bottom one is x squared plus 9. Let's see what is special about this one when you compare them with the other one. Any suggestion? You have to exclude, of course, the number of the x, values of the x that make the numerator equal to 0. The number is x squared plus 9. Any suggestion? Can you find any number?
Could you simplify the x's?
Oh, no. How do you want to simplify? No, you can't do that.
Is it just -7?
No.
Would the domain just be all real numbers since x is being squared at the bottom?
Yes, you are right. It's all real numbers. But the reason is, you see, look at this one.
Yes.
You
It's
can't factor x squared plus 9.
excellent. That's one. We cannot factor x squared minus plus 9. We can only factor x squared minus 9. Remember, no complex numbers if you are familiar with. But x squared plus 9, we cannot factor it. If you cannot factor it, you cannot let it equal to the 0 to find those numbers. You see? So x squared plus 9 is non-factorable. So therefore, x squared plus 9 is never 0. Because if you pick any number for x, to make it 0, you need a negative number. You never get a negative because it's x squared. Okay, so since it's x squared plus 9, so it's safe. The domain is all real numbers. Okay, so that's very special type or example of the group of the rational function. So that's it. So this is the way we're going to explain it. We explain that the x squared plus 9 is a non-factorable. It's not factorable. It's not factorable. And so X squared plus 9 is never 0. It's always a non-zero number. So we have no difficulty because our X is free agent. You see, this is the X. From negative infinity to positive infinity. It's free unless you restrict it. There is no restriction because the denominator is automatically a non-zero number, okay? So the domain of this function is all real numbers, negative infinity and positive infinity. And then you're done. So, make sure you don't miss it. This is, as soon as they talk about the rational function, they bring this one and they ask you the question. Okay, any question? I should give you one more. This next one, sometimes you make a mistake and you miss it. Let's see what's so special about this one. Number 6. What's so special about this one? F of X equal to X minus 1 on the top. X squared minus 1 down the bottom. We want to know what's the domain of this function. Any suggestion? Or what we are going to do? Again, it's a rational function, okay? You check to see if the denominator can be 0. So find the values or
Is it
what
just
value?
1?
Okay, let's see. Why just 1?
1 and negative 1?
1 and negative 1, yes. It's a 1 and negative 1. The reason that I gave you this problem is, you see, we talk about it, we factor it first, okay? Let's see, solution, because X squared minus 1 can be factored. So it's going to be F of X equal to the X minus 1 on the top. Down the bottom would be X minus 1 times X plus 1. See? Some people, as soon as they factor it first, then they cancel out the X minus 1 and X minus 1, which is not correct. You can't do it. You can't do it at this time, okay? You can't do it at this time because you have to find the domain of the function first. So ignore it. When you want to find the domain of this type of function, you just focus on the denominator. The denominator would be 0 at 2 places, 1 and negative 1. So this function is defined everywhere except that 1 and negative 1, okay? So don't simplify it. Because if you want to simplify it, you have to find the domain first, then you do it. Because the function would be identified with its domain. So it's like a name. This function must have a name, an identity. Then you should, you'll be able to simplify it. Okay, some people, they miss it on the test. They go and they simplify it. No. So X would be 1 and negative 1. So I want to finish it here. So I give you this one. It's from negative infinity to positive infinity. 2 numbers to exclude. We have to exclude the 1 and negative 1. So we exclude the negative 1 from here. And this is going to be a positive 1 from here. 1, 2, 3 partitions. So D is equal to, you start from negative infinity, you go to the negative 1. Union with a negative 1 and positive 1. Union with 1 and positive infinity. This is going to be the domain of your function. These are all the examples, all we need for these rational functions. Any question? So the rational function is going to be a kind of a red flag. So be careful about it, okay? You will see one of them in your next quiz, okay, quiz 1, then you are going to see it again in test 1. And through the course, we bring these as an examples. And anything you want to do, you have to find the domain of the function first in this course, okay? Any question? So that's a second group, the rational function. We have another one. So what's going to be the next group? The next group are going to be radical functions, okay? We are going to have the radical function from time to time. In calculus, when you want to find something, to have something which is going to be different, they usually bring the radical function, okay? So let's go with the radical function. That was number Okay, number 5. So we go to the number 6 and we introduce a radical function. A radical function, you know that the variable x is going to be inside a radical. So we start with this one. F of x is going to be equal to the square root of the 3x minus 6. Okay, with the radical function. Now, when we go with the radical function, you see this is the square root. We say that the index of this radical is 2 because it's a square root. If it's going to be cube root, there is going to be a 3 here. So that 3 would be the index of the radical. If it's going to be 5, the index would be 5, okay? So what you are going to do, you have to look into the index of the radical. If it's going to be the square root, 4th root, or the 6th root, this inside cannot be negative. You know that. You cannot find it. We talked about it already. We cannot have radical negative 4. Doesn't make sense. So you have to look at the index of it. If the index of the radical is odd, the cube root, the 5th root, the 7th root, nothing to worry about. Because we can find the cube root of any number you like. Positive number, negative number, and the 0. But for the square root or anything with the even index, you have extra work to do. So this is going to be the solution. To start with, index of the radical. Index is 2. It's a square root, index is 2. Cube root, the index is 3. The 5th root, index is 5. We say that the index equal to the 2 is even. Then you are in trouble. Since it's even, and so, just for your information, f is defined. F is going to be defined when the inside 3x minus 6 is not negative, means it's greater than or equal to the 0. Okay, so since the square root of a negative number doesn't make sense, you have to guarantee that this 3x minus 6 is going to be greater than. So there is a restriction on the x. You have to solve this inequality. You know that you move the 6 to the other side. That gives you greater than or equal to 6. Then you divide it by 3. So x would be greater than or equal to the 6/3. And the 6/3, you simplify that, give you x greater than or equal to 2. So this function is defined when x is greater than or equal to 2. But would like you to give us interval notation. So when we go to the number line again, this is 2. We make it solid because there is equality sign here, you see. This means 2 can be included. That's why we use the 2. Okay, we use the solid. Greater than. Greater than, you go to the right. Less than, you go to the left. So this is going to be your domain, if you like. So the domain of the function is going to be 2 and positive infinity. You never get to the infinity, so it's a parenthesis. But 2 is covered, is a solid, so use bracket. So this is going to be the domain of the function. Okay, so for the square root function, you have the restriction. The restriction is this expression cannot be negative. So you have to force it to be greater than or equal to the 0. 3x minus 6 greater than or equal to the 0. You solve for x, that gives x greater than 2. Greater than 2 is going to be 2, you go to the right and positive infinity. If it's going to be less than 2, it's going to be negative infinity up to the 2. Okay, so 2 different cases that we are going to consider. Any question?
I actually have a question. If it was an open dot on the number line, when you're listing the domain, would it also be a parenthesis instead of a bracket?
Yes, that's it.
Okay.
Yes, yeah, open dot. For the rational function, because we cannot have that number to remember
Right.
as denominator. But over here, it's fine because if you put x equal to 2, you see,
Yeah.
that gives 6 minus 6 is 0. Square root of 0 is 0. So
Right.
that's why, we pick the x.
Thank you.
Okay. Any question? So that's a case with the even index. If the index is odd, that's the easiest case. Number 7. Number 7, you may be given this function, g of x is equal to, okay, is equal to the cube root. Okay, cube root of x to the 5th minus 3x plus 1. You see this one? Since the index is odd, you can pick any, cube root of any number. So forget about the radical. Just check this one, x to the 5th minus 3x plus 1. Which type of function is this one? X to the 5th minus 3x plus 1 without radical.
Polynomial.
Polynomials. And we know that the polynomials are defined everywhere. You see, when it's an odd index, that's a very good case. So the solution, say that the index of this radical index is 3, is odd. When it's odd, there is no restriction. Cube root of, for example, 8 would be 2. Cube root of negative 8 would be negative 2. Cube root of 0 would be 0. So we can use any time, okay? So index is odd, so the inside is a polynomial. And so the domain is all real numbers, negative infinity and plus infinity. So G is going to be defined, okay? G is going to be defined everywhere. Okay, any question? So this is the radical, but there is one case for the radical, it's a little bit tricky. And it's a very popular function that we are going to beat it in future. So that give you that one too. So to finish it, so it's let's see what is special about it. Okay, let's have this function f of x equal to, and this is going to be the 4th root of x squared minus 9. You will see this one in chapter 3. Is this function several times, in fact. So we want you to prepare you to get these numbers. Okay. No. When the index is odd, you see, when the index is odd, you forget about the radical, you look at the inside. This happened to be a polynomials. In your case, it's going to be polynomials all the time, but it can be anything else. I'll give you one example. Let me finish this number 8. You may have a rational function inside. Then you got to be careful. I'll give you one in a minute. Okay, let's see what's special about this one. You see the index of the radical, you have 4, okay? 4 is an even number. Okay, 4 is going to be an even number. So since this is going to be even number, so this, you know that there is a restriction. So the function is going to be defined. Okay, the function is going to be defined if the inside is going to be positive. So solution, this is how we're going to describe it. So an index of this radical, index is equal to 4 is even. When it's even, remember we have restriction. You have to guarantee that this is not going to be negative. So and so, if you like, and so f is defined. Okay, f is defined when this expression x squared minus 9 is going to be greater than or equal to the 0. Okay, so since the index is even, you have to put this restriction on it to get the numbers. Now, okay. Now, what you are going to do, you have to solve this inequality to get this number. Any suggestion? I'm going to solve this one. You know that the power is 2, it's not 1. Any suggestion for this one? There are different ways to do it in algebra. I just want to see what it's going to be your idea.
Is it? Oh, okay.
No, not this square.
Well, would you do x minus 9? No, maybe not. Or x minus 3 and then x plus 3
Yes, this is one.
to equal 0.
Yes, very good. Yeah, that's a standard method that we're going to do it. Let's try this one that you talk about it, then I'll give you another format. Yes, you know that officially, this is called a polynomial inequality in algebra. If it's going to be x, we can move the 9 to the other side to get it. But if it's going to be other than x squared, we factor it first. One way to do it is factor x minus 3 times x plus 3. You want it to be greater than or equal to 0. The way we do it in algebra, we let it equal to 0 first. So you are going to arrive at two numbers for x, positive, negative 3. Okay, so this is going to be the one. Now what you are going to do, you are going to partition the number line. You see this is going to be the number line from negative infinity to positive infinity. You partition it by these two numbers. The numbers are going to be a negative 3 and a positive 3. So you have to check, you see the numbers in this 3 partition, 1, 2, 3. You have to check to see what's going to be the sign of the x squared minus 9 in each partition. Okay, in each partition means you pick a number between negative infinity and negative 3. Give us a number. A number? Anything?
Negative 5.
Negative 5. We call it the test number. We put the 5 here. So x squared minus 9. Use parentheses, going to be negative 5 squared minus 9. 5 squared minus 9 would be 25 minus 9, which is equal to the 16. 16 is a positive number. So we say that in this region, x squared minus 9 is positive. You put the positive here. Okay, then you go to the next region. Between negative 3 and positive 3, pick a number. Easy number. Easy number?
2.
Okay, easier than. You mean, yeah, you can pick 2. If you like.
0.
Yes, 0 is the best one. If you put 0, so we put x squared minus 9 and we put the 0 in it. So that gives you 0 minus 9, which is a negative 9. It's negative. So in this region, the expression is negative. Okay, and we need another number here. Okay, give us a number between 3 and positive infinity. Number?
10.
10. Yes, you can pick the 10. Okay, 10. You like 10? 10. So we find x squared minus 9 for 10. That gives you 10 squared minus 9. It's 100 minus 9. It's positive because it's 81. So that gives you positive. Okay, so we check the sign of the x squared minus 9 in these 3 regions, if you like. But what you are looking for where x squared minus 9 is positive. So it's going to be positive here. Okay, so it's going to be positive here. And it's going to be positive here. So the domain of your function is going to be, I write down here, the domain is equal to 2 portions from negative infinity to negative 3, negative infinity to negative 3, union with what? 3 and positive infinity. 3 and positive infinity. That is
For the 10, isn't it 91 or?
Oh, okay, 91.
Okay, yeah. Thank you.
Yeah, okay, that's positive. So, so you see, you have these 3 partitions. So your solution is going to be among these 3 partitions that you have. So you are interested in the partition where this expression is going to be positive. So as we tested, it's going to be positive in the first partition, or it's going to be positive in the third one. So when you want to put them together, you are going to use this notation. We call it the union notation to get these numbers.
Professor,
Yes.
because the -3 and the 3 have the black dot on it, does it not have the
Excellent. Yes, you are right. I missed it. Very good. Yes, bracket. Because, you know, if it's going to be x equal 3 or -3, this would be 0. X squared minus 9 0, that's going to be 1. In the case of the rational function, then use parentheses because you cannot have the 0 down the denominator. But for this, yes, you are right. Very good. The bracket 1. Okay, so this is standard method you need it for future. This was an excuse. I'm going to give a shortcut to do this problem. But this method is going to be used in future, okay? It's going to be just 1 or 2 cases that we have to use it. So that's what we just remind you about solving this type of inequalities by using these test numbers. But any question, this one? But there's a short form of this solution. I give you that short form. I like the other one, but we don't mind if you do this part, okay? Let me just give you a shortcut.
Excuse me, Professor, I have
Yes.
a question.
Yes.
So doesn't matter which number you put between those range, you will still get plus minus, you will still get positive, negative, positive?
Yeah,
Okay,
yeah, you can try it.
all right, thank
Any
you.
number. So pick something easy
Yes,
because
all
you
right.
have, you have a choice. Now, the other solution is going to be to get these numbers. If you are interested in algebra, again, you see in algebra, this x squared minus 9 is a quadratic expressions because of the 2. And you have 2 solutions. You have it in algebra that if the quadratic expression would have 2 solutions, -3 and 3, between the solution, the sign of the expression is opposite sign of the x squared. You see the sign of the x squared is positive. So opposite of the positive would be negative. Everywhere else is the same sign. Done. Okay, if you have a quadratic, only quadratic x squared. If you have a quadratic expression with 2 solutions, -3 and 3, between the -3 and 3, the sign of the expression, the sign is going to be opposite sign of the x squared. Sign of the x squared is positive, so the opposite would be negative. Positive, done. In algebra, if your quadratic expression has no solution, just one solution, the sign of the expression is the same as the sign of the x squared. It's not a big deal, you can test the number, just take care of it. But in case you want to know it, but there is a third method. I like that third one, and we need that one from time to time. Any question? This is a valid method, okay? You can use it anytime you like, and refresh your memory regarding this because we need it for future. But the other format, the quick solution of this one is, this is a method 2. Okay, method 2, where you see the idea is solving this one, x squared minus 9 greater than or equal to the 0. The way we can do it, just add the 9. Add the 9. Take the square root. Radical x squared greater than or equal to the radical 9. Okay, what's radical x squared? Any suggestion?
X,
X. Any other suggestion?
-x?
Negative x. Any other suggestion? No, you haven't got the correct answer yet.
what was the question again?
The question is, what is radical x squared?
±3.
No, it's not. Okay.
plus or minus X.
No, it's not. let's see what's special about this one. You see, since it's a square root, the output must be a positive number only. So it cannot be positive and negative x. The result is one number and it must be positive. You see, if it's a radical 4, you know that the answer is 2. And the radical 9, the answer is 3. It's not positive, negative 3. Okay, you get only one solution. So in order to guarantee that the result is always positive, radical x squared is absolute value of x. You see, that's going to be the one. So you know that the absolute value of x, then what's the absolute value of x? Depends on x. If x is positive, absolute value of x would be x. If x is negative, absolute value of x would be negative x. So in any case, your result is going to be a positive number. When you are in algebra, you see, you are going to be relaxed over there. Sometimes they say, we have two solutions, the positive solution, the negative. It's not really. There is only one solution, and that solution must be a positive number. To guarantee that's a positive, it's going to be absolute value of x, greater than or equal to radical 9 would be 3. You see? And that's going to be the way we operate it. But the absolute value of x is your distance from the origin, from home. You see, to find this result, you put the number line. This is from negative infinity to positive infinity. This is home, 0. Okay, that's going to be the origin if you like. So when you say the absolute value of x is bigger than 3, this means your distance from your home is greater than 3 miles. So that's a 3 miles. Greater than 3 means you are here. But you may have different direction going home from the right or the left. So if you are here, that gives you a negative 3. Again, you are not going home, so you are going to be here. So absolute value of x is greater than 3. This means x is either greater than 3 or it's going to be less than negative 3 here. So the domain of your function is going to be negative infinity up to the negative 3, parenthesis bracket, union with, okay, union with 3 and positive infinity. That gives you the domain. That's the way we usually operate in calculus to get these numbers. Okay, so we take the square root of both sides quickly. Radical x squared would be absolute value of x. Okay, it depends on what the x is because we don't know the x. Okay, so greater than 3. If the absolute value of x is going to be less than 3, means you are within the 3 miles of your home. Means you're going home. You are going to be between negative 3 and 3. When it's greater than, you are far from your home. You are not going to be within the range of your home. So either you are going to the right or either you are going to the left. So to the left of the negative 3 would be negative infinity and negative 3 bracket, union with the other one. So that gives you the domain of the function. Okay. So the bracket is when it's equal to equality. You see, x can be equal to 3. So that's it, put the negative 3 and the 3. We use bracket when it's reachable, if you like. If we can find it. If it's not going to be fraction, we can use bracket because that number can be, okay, you can have that number too. So I'll give you another one. So you compare them together. We have 2. So you have that option for the test or the quiz. It's a very popular function in calculus. Eventually, we are going to craft this function, you know, when we get to the chapter 4 or chapter 5. So this would be one of those tricky functions that we're going to have. So that's why we want to get to know it. Any question? So this difficulties arises when the index, of course, is even. You see 4. If the index happen to be odd, and nothing to worry about. Okay, the function is nicely done. I'm going to switch that to 9 and x squared because this is the second case, so that we have all the possible collections. So that was number 8. I change it a little bit. Look at this one. Suppose your function is g of x equal to even a square root of, okay, I give you this one, 4 minus x squared. You want to find the domain of this function, index is 2 because of the square root. Since the index is 2, you are going to be in trouble. You have to determine where the inside is going to be non-negative numbers. Okay, so this is how we are going to solve it. Solution. Index is 2. 2 is an even number, even. And so, again, G is defined. G is going to be defined when or where, when 4 minus x squared is greater than or equal to the 0. Again, you can factor it if you like, but I want to use that short form to show you why these two problems are different. I'm going to subtract the 4, so it's going to be negative x squared greater than or equal to the negative 4. I don't like this negative, so I want to multiply by negative 1 or divide by negative 1. And you know that when you divide by a negative number, you reverse the sign of the inequality. So that gives x squared less than or equal to 4. Okay, any question? So we multiply both sides by a negative number, or we divide by a negative number. When you divide or multiply by a negative number, you have to reverse the sign of the inequality. Now I take the square root. I just use the square root method to take care of this one. So that would be a radical 4. We talked about it already. This is going to be absolute value of x. This would be 2. Go to the number line. Negative infinity, positive infinity. Pick the origin, 0. Then you have the 2 to the right, negative 2 to the left. The absolute value is a less than 2. Less than 2. This is 2. Less than, you are going to be inside. So this is going to be your domain, inside of the negative 2 and 2. So look at the other one that we did. The other one was greater than. You see, x greater than 3. X greater than. That's why you go to the right here and the symmetrically mirror image to the other part. So be careful, it's going to be less than, you're going to be within the 2 miles of your home. You're going home. So the domain is going to be negative 2 comma 2 bracket for both of them, because the radical can be also 0. Okay, so this is 2 possibility for, this is the most radical function that you can have in calculus. So pay attention, we give all of them and we're going to repeat it. You know, we bring them back again for the example of other concepts that we're going to cover. It's interesting to know. Any question? So this is the 3 important groups of function. Polynomials, the domain or real numbers, that's it. Rational function. For the rational function, you must guarantee that the denominator is not 0. So there are some numbers that you have to remove. Okay, for the radical function, 2 cases. The radical with the odd index is free, the domain is all real numbers. But the radical with the even index, you have work to do. This is the one that you do. You have to impose some condition on the x so that you are going to have only a positive number. When it's a square root, the index is 2. Index of the radical with the square root is 2. Otherwise, the index cannot be equal to 1. You see, that's 1. A square root is index is 2, then the cube and the fifth 6, then you have those numbers. Okay, I'll give you a break now. These are the classic functions. We have, of course, another type of function that we have to investigate before getting to our main parts. And that would be those famous function, piecewise subfunction. These are a nice function and we use them quite a lot. But the one that we are going to have for calculus most of the time is piecewise defined. So we discussed that one too, so that we are going to be ready for it. Okay, any question? So let's have a 10 minutes break. This is 8:37. We come back and we finish it with the introduction to that piecewise defined function. So we have all the tools that we need. Then we can start talking about the limit of the function next time. Okay, see you in 10 minutes. Okay, let's see. Okay, so what we are going to do is we just need to talk about another class of functions, very famous one. What is going to be the piecewise defined function? So study these examples carefully, because these are going to be given to you from time to time of tools. You know, and at the beginning, we give you this and we ask you to find the domain. Later on, we have some concept we call continuity, differentiability. Everything we want to talk about it, we bring these functions. And then the domain is going to be repeated for those purposes too, okay? So study these. If you have any question, let me know, but you will see them two groups in your practice test. Quiz number 1, I will post those over the weekend so that you can have a look. Okay, now we need this group of functions, okay? So it's going to be called piecewise defined. I gave you various examples. Remember, the post office, the tax, utilities. So what's going to be piecewise defined functions. You see, sometimes when we want to define a function on its domain, we have to break the domain of the function. We partition the domain. So we are going to use more than one equation to define the function. As I told you at the beginning, they didn't believe in this type of functions and they rejected. It was application in science that they forced them. So a function f, give you the definition. A function f that is defined, that is going to be defined by several equations. It's going to be 2 or more. Several equations. It's going to be defined by several equations over its domain. Over its domain. Okay, over its domain is going to be called a piecewise defined function. It's called a piecewise defined function. Defined function. We have different brackets, okay, to define the function, like the taxes, post office, you know, cell phone. Okay, example. Get this one, the typical one is this. Suppose we have a function f of x is defined by 2 equations. First equation is x squared minus 3x. But if x is going to be less than 2. So when x is less than 2, the machine will bring this formula, x squared minus 3x. But it's going to be equal to the 5x minus 2. 5x minus 2 when x is greater than or equal to 2. So we partition the function around the 2, if you like. Okay, so this is, if this is going to be the case, then f is a piecewise defined function. F is going to be a piecewise defined function. So you can, you can imagine that you see this is going to be the domain of the function. You start from negative infinity to positive infinity. So what you have done, you partition the number line at 2. So this is going to be 2. Okay, that's going to be 2. So if your input is going to be less than 2, means if you are here, so the machine would use this formula to get the function, to get the y, if you like, the output. So in this case, y is going to be equal to x squared minus 3x. Okay, for the input which is less than 2. But if your input is greater than 2, you have to use this formula. Okay, so if you are here, so your output would be 5x minus 2. At the partition, depends where you are. You see equality is coming with the second part. So using this formula to get these numbers. Okay, so if you want to operate with this function, you see note that. Suppose you want to find f of 1. You have to decide where is the 1. Is it in the first partition or is it in the second partition? 1, what's the answer? 1, you see, 1 is going to be in the, okay, in the first partitions, okay, yes. You see 1 is here. So when you want to find f of 1, you have to use this formula, x squared minus 3x. You know that you cannot use both of them. So it's going to be, that's it, that give you 1, I just write it down, you know that which formula I'm using. 1 squared minus 3 times 1, which is going to be 1 minus 3, the result is going to be negative 2. So you realize that f of 1 is going to be equal to the negative 2. Any question? You cannot use both of them because if you use both of them, you know that you're going to have, you have to have the common first component if you like. For each x, you must get only one y. For each x, you get only one y out. So we use the first one. Okay, any question?
So if f was like 5 or something, then it would be the second one.
Yeah, if you want to find it at 5, yes.
Okay.
See, for example, suppose you want to find f of 3. Where is the 3? Is it in the first partition or is it the second partition? You see the second partition, 3 is here. Because 3 is greater than 2. So in order to find the f of 3, you have to use the second one. So that gives you 5 times, okay, 5 times 3 minus 2, which is going to be 15 minus 2, the result is going to be 13. So f of 3 is equal to the 13. Okay, it's like you show your ID, okay, and then they give you the result. That's the case that we are going to have for this type of problems. Okay, the important part is what is going to be f of 2. You see f of 2. 2 is a partition point. You see this is going to be the partition point. So you check to see where do you have equality sign. You see there is not equal to here, so you cannot use the first one. But there is equality here. You can use it. Sometimes you may not have the equality sign at all. So in that case, f of 2 is not defined. Okay, it does not exist. But in this case, the second part is coming with the equality sign. So we are going to use the second part. So it's going to be 5 times 2. 5 times 2 minus 2. So that gives 10 minus 2, which is equal to the 8. So f of 2 is going to be equal to the 8. Any question? So we wanted to be able to work with this type of function. Everything we do in calculus would be related to this partition point, the 2 that we have over here. But it's nice to get to know it. Any question? So what else do we need? You see, this function is going to be used quite a lot, especially the graph of this function is going to be used to just, to explain various concepts in calculus. And you'll be able to work and to see the result from the graph of these functions, okay? So this is going to be the question that we're going to be interested in. Very mild one, not anything difficult. We wanted to sketch the graph of one of these functions for us, okay? So I need more room, so I go to the next page. Any question? And by the way, the domain of this function is going to be all real numbers. You see, when you want to determine the domain of the piecewise defined function, you just check this partition point to see if it is covered or not. If this equality is missing, they may give you something like x squared minus 3x when x is less than 2, 5x minus 2 when x is greater than 2. If that's missing, this function is defined everywhere except at 2. But if the equality is given to, you can see that the domain of this function is all real numbers, negative infinity and positive infinity. Because the numbers can be less than 2, or the number can be greater than 2, or the number can be equal to 2. So you have all real numbers with no restriction for the domain of this function. Question? Now, the graphing part is that we are going to be having a disagreement, if you like. So I'm going to give you instruction and you have to follow this one. The way you do it in algebra or in college algebra is not like the way we do it in calculus. So make sure don't miss it because this question will be repeated twice in this course. And you will see, we give you one of them to sketch the graph of that on your first quiz, and then in test one, we repeat it again, okay? So this is the example. Let's study it carefully. So what's this example? We want to sketch the graph, that's it. Sketch the graph. Okay, sketch the graph of the function. Of course, the function is going to be a piecewise defined. This is the function, f of x. And we are not going to give anything complicated for the time being, okay? Just going to be a straight line. So a linear one, 2x minus 1, when x is less than -1. That's the first part. And we have x plus 2 when x is greater than or equal to -1. You see? This is the function that we want to graph. Okay, the way we graph it, you see it's a two pieces. The first part is y equal to the 2x minus 1. And the second part is y equal to the x plus 2. We are going to consider each case. We graph it. Of course, we graph both of them are going to be in 1 xy coordinates. There are going to be two possibilities. These two graphs may be connected to each other, or they may be separated. Okay, so this is how we're going to find out. So the solution is going to be, we graph the first one first. So the first one would be y equal to 2x minus 1 with the restriction that x is less than -1. So the numbers that you are allowed to pick are going to be number less than okay, the number must be less than -1. You see, that's a straight line. You need 2 points to graph it. So the point that you're going to pick are going to be the following. You see, you get the x, y coordinate, x, and this is your y, and the formula to be used is going to be 2x minus 1. You see, since the restriction is your number must be less than -1. So what you have to do is you have to pick one of the numbers to be -1. The partition point. We pick this number to make sure that we are not going to go over, okay, less than. Then you pick a number, another number, it's going to be less than -1. You see this is a -1, the next number is going to be a -2. That's it. Okay, so you must start with the -1. Some people argue and say, oh, there is no equality sign. How should I take the x equal to -1? Doesn't matter. In calculus, we estimate. Okay, we estimate it. So we're going to take care of it, don't worry. And you have to pick that number first. Okay, so pick the partition number, something less. Now substitute to get these numbers. So this is it, a -1 that give you 2 times -1 minus 1. which is going to be a -3 minus 1. Let's get -2 minus 1, which is a -3. Okay, that's 1. And over here, you substitute. If you put the -2, so that give you 2 times a -2 minus 1. So that give you a -4 minus 1, which is a -5. Okay, nicely substitute. Now we're going to graph it. I'm going to graph it, get the XY coordinate here. That is going to be your XY coordinate. Locate these points. It's a -1 and -3. This is it. -1, -3. That's a 1, 2, 3. That's a -3. This is going to be 1 point. Okay, that's going to be 1 point. Then as soon as this is just a partition point, you just check to see if, you see, -1 is not covered here. So what you're going to do, you're going to make a hole here. See? If it's equality sign, you make this one solid. So we didn't lose anything. X is not equal to -1, and we identify it here. So that will help you to get the good image of your graph, because you have to, your graph should define everything up to the -1, up to the -1. So we get the -1 out. Okay, so it's nothing to worry about. It's like I invite you for the party, I invite you for the meeting. You didn't come, but your chair, your seat is empty. So that's exactly what it is. Okay, so this is going to be the first one question. Second point. -2 and -5. -2. -5. That was 3, 4, 5. -5. -2, -5. This point is part of your graph, of course. So what we're going to do, you are going to connect these two together, but you go only to the left. Because remember, X is less than -2. You see, this is less than -1. This is a -1, less means to the left. The reason that I picked the -1 is make sure that you are not going to go to the right. Some people, they graph this one right like the one in algebra. There is a restriction, your X is less than -1. So you are allowed to have only this portion of the graph. Okay, so this portion of the graph would cover when X is less than -1. Any question? So make sure that you start with the partition point. I've seen some of them, some people on the test, they don't do it. They say, I don't have the equality. We give you 0 right away. We don't care. Because if you don't pick, you see, some people, they start with the -2. So there is going to be a gap. You see, you graph it and you don't give us anything between -2 and -1. So you miss this portion. You see, that's why we estimate it. We put the -1 first, but the only point that is going to be excluded is just the partition point. So everywhere else, we have a nice one. So don't miss it. That's the way you have to do it. Any question? You're not done? That was the first part. Okay, we repeat it again for the second part. Okay, so go to the second part. So the function is going to be y equal to the x plus 2, the second part. The restriction is x greater than or equal to the -1. Again, 2 points. See? This is your x, this is your y, x plus 2. Again, your first point must be the partition point. Because you must know where to start. You see, it's -1 up. -1 up, then get another number up. Something bigger than -1. Close and bigger, you can pick 0. You can pick, any number you like. You see 0, negative 0, positive 1, 2, but pick something nice and close. So that give you a good idea of what's going to be the nature of your graph. Okay, now substitute. So that gives us a negative 1 plus 2, which is equal to 1. See, compare these two numbers together. Look at this one. In the first part, you get negative 1 and negative 3. In the second part, that give you negative 1 and 1. That will tell you something. That will tell you that the first part and the second part are separated. You are not going to be able to connect them together. If these two numbers happen to be the same, the first part and the second part would be connected to each other. Again, this is another advantage of picking a nice number, a nice choice. Okay, so we put the 0, 0 plus 2. Yes, give us 0 plus 2, and the 0 plus 2 is going to be equal to 2. Okay, go back to the same XY coordinate and continue your graphing. We have a negative 1 and 1. This is a negative 1. 1. Suppose this is 1. So this is going to be the point here. Again, you check to see if there is equality. You see equality sign here? Since it's equality, you make this one solid. Look at this one. You have a solid and the empty point. You cannot have both of them to be solid. If it's going to be both of them solid, this graph is not a function. Okay, that's why they arrange it so that you get this situation you have. Negative 1 and 1. So when you identify the partition point, if the equality sign is missing, make a hole. If the equality sign is given, you make a solid point. Okay, the next point is going to be 0 and 2, x equal to 0, y equal to 2. So that would be 2. So it's going to be your next point. And then you start with the partition point. You know that this time you have to go to the right because x equal to negative 1 up. So this is going to be the second part of your graph. So this is the graph of the function. It's the two pieces. It's going to be two pieces. The first piece is x less than negative 1. The other one is going to be x greater than negative 1. When we get to the first concept in the next section, which is the limit of the function, these type of examples are going to be very important for us. Because we estimate the value of the function when x is less than negative 1 and bigger than negative 1. And this would be a very interesting case. And we need them. These are going to be our good examples, if you like, that give us a better understanding of the concept of the calculus. Okay, any question? So we give you some to practice and try to just practice the way we are going to do it in this course, not the way you did it in college algebra. So make sure that your graph give us all the information that we need at the partition point, at the negative 1. So to get this at the negative 1, you start with the negative 1. You see that's it. It's the negative 1. And then something less, which is a negative 2. You identify these 2 points, get it on the number line. When the first part, you don't have the equality sign, so you make it a hole. Then we go to the second part. Again, you pick the negative 1 first. Negative 1 up, that give you negative 1 and 0. You identify the points. Negative 1 is covered here. So that's why we make it a solid point. And it's up. We are not going to go down anymore to get these numbers. Okay, and from time to time, we are going to use them again. So what is the question?
When we do a graph like this, do you want us to use like 2 different colors so you know what we're graphing, or could we just do one? Okay.
I like the colors, but you don't have to. But make sure you get it. So the question is, what's the question for the red 2 connection? Do we make it another empty? No. You cannot have both of them to be empty, you see? If the equality sign is missing, you have to make a hole. Yes, it's going to be the case that if this function is given to you, see, if you give it a function that x is less than negative 1 and x is greater than negative 1, If there is no equality sign, then when you graph it, you are going to have two empty points, if you like, two holes. So equality, when you identify it, we must see it. Equality part is going to be coming with the, okay, with the equality sign. That give you a result. So you have to have the partition one to make sure that for the first part, you are going to go over. You see this is a -1 down. And even for the second part, you want to make sure that at what part are going to pick these numbers to get the results. Okay. Any question? The piecewise define. So why are the points -2, 5, -2, and no, you don't need the circle for the other ones. You see, the question is why I didn't circle these points. No, you only have to identify the partition points, not any other points. Just the partition, because this is the point. The rest is the graph. You see, the rest is going to be the graph. It's just one point. You continue to get, to get it up here. So you only care about that partition point. That's the starting point. You see, the end point for the first part and the starting point for the second part. This is it's important. Not any other point. No, that is going to be the case. You have to give us that, that partition points. Okay. Any question? And you will see quite a lot of this type of function that we're going to have. Okay, so we are done with the review that we need for this graph of the function, and this is section 1.4. And now we are ready to get the calculus part, and we do it next time. So what we are going to do so read this carefully. Okay, that would be quite important for you to understand these functions. And these are your tools. So from time to time, you are going to see them. So study carefully. Then if you have any question, bring it back quickly to make sure that you understand the concept of the function. And then when we apply it, then you enjoyed it. You are going to use all of them. Okay, so what we are going to do for the calculus part. You see the calculus, I talked about it the other night, it's a study of a rate of change. So what we do in calculus, we estimate. You see, look at this one. When you put the numbers inside, it's not estimation. It's finding the exact value. You see, exact value at 2, exact value at -1, etc. But the way we are going to do the calculus part is we are going to estimate the value of the function around this -1, if you like. So we want to know that what is going to be the value of the function when x getting closer and closer to the 2, if you like. So just the idea is like the one that you did, kind of the one that you do before. And just before you go, I just want you to see, just think about this example that we are going to, this is the way I'm going to justify the concept of the calculus later on. You see, answer this question. We want to run, okay, run the numbers, okay, the given numbers to the, okay, to the 10th position. To the 10th, okay, that's one. I think that's correct. Okay, so the numbers are going to be, let's have 1.52. That's the first one. And the other one is 1.5, let's say 7. That is going to be the case. Okay, we want to run that to the 10th place, if you like. What's the solution? The first one. 1.552 if you want to round it to the 10th place. Any suggestion? Yes, you get the number. Yes, it's going 1.5, 1.5. Yes, you are all right. Yes, 1.52. If you run it, it's going to be an estimate. It's going to be up to the 1.5. Okay, when you run it to the 10th place. Very good. Okay, what does it mean? Run it to the 10th place. You give us a 1.5 right away. This is because you know the instruction. The instruction is, you know that you have to, you identify the rounding digits. This is going to be the 10th place, the rounded digits. You look to its right. You know that if that number is going to be what? If this number is going to be less than 5, you ignore it. But if the number is going to be greater than 5, we give you the second part. You see the second part is a 1.57. So you know that this is the rounding place. This is 7, you round it to the, you get a 1.6 to get these numbers. Okay, that's the instruction. What does it mean, round it to the 10th place? Because this is the instruction that you got 1.5. Can you explain it? Rounding to the 10th place, 1.5. So what? What does it mean? Any suggestion? Okay. Yes, any comment?
You would just find the 10th place of the decimal and then round up or down depending if it's closer to 5 or below it.
Yeah, that's the instruction. What does it mean? So what does it mean, this your procedure? So what? Round it to the 10th place. You can round it to the 100th place, 100 to 1000th place. Which one is better when you round it to the 10th or 100th or thousands? That's the foundation of calculus. You see, when you run something, you estimate it. When you estimate, you may lose or you may gain something. In the case of the 1.52, you lose something, you lose 0.2. You get to the 1.5. In the case of the 1.7, you gain something. You gain something, you make it into the 1.6. So the amount, your tolerance, if you like, your tolerance, amount that you're prepared to lose or you're prepared to gain is going to be this 10th place that you talk about it here. And so this means the difference between, this is just an estimate, 1.5. 1.5 is the estimate, but 1.52 is just the exact value. So this means the difference between these two, the difference between the actual one that you find and the actual one and your estimate is going to be less than 1/10. So your tolerance is less than 1/10, if you like. So when you say it's rounded to the 10th place, rounded to the 10th place means you are okay with if you just losing something around the 10th place. It's like when you go shopping. You see, if you go shopping and they say it's 99 cents, and if you produce $1, you don't usually wait to get the change because your tolerance is 1 cent. That's fine with you. But if you give $100 and it was 99 cents, of course you are going to wait to get the change because your tolerance is not going to be something like $99 to lose. So this loss or gain, we usually refer to it as a percentage of error. So there's going to be an error in estimate. In that error of estimate is going to be 1/10. So you round it to the 10th place, and it's going to be the same for the other part. So this is going to be kind of things that we're going to do. for the limit of the function. I'll give you more next time. We are going to find the value of the function around the given number. So we may run the result to get this. I talk about this one again next time. I teach, there is a course I teach to the future teachers at the university, and they have this concept of the rounding. And they have this type of idea and nicely explain it. Since I teach calculus, I know that they are talking about calculus, but they put it into different formats. So I give you the definition and then we talk about it. And the section that we're going to cover is the big one, is 1.5. It's very dense section that will take us to your first quiz. Okay, you can have a look if you like, but the way we are going to talk about it is a little bit different from your book, but it's the same thing. So 1.4, make sure to get the problems. I will post the problems for you. Start looking at 1.5. Then we talk about